Homework 3.5, Rational Functions Video 3. This will be another video that is based in Desmos, so let's go down there. Let me set this down. Let me walk around. And let's do it. Okay, so in the previous two videos, we talked about what's called asymptotic behavior. In other words, as x approaches a vertical asymptote, does the y go to infinity or negative infinity? It depends which side of the asymptote. On this one, if I come in from the right side, I'm going up to infinity. But if I come in from the left side, by the way, you can do what I'm doing by just pointing on the graph, clicking and holding, and then dragging. But as I'm coming in from the left side of this asymptote, I'm going to negative infinity. The exact opposite over here. If I come in from the left side of the asymptote, I'm going up to positive infinity. And if I come in from the right side of this vertical asymptote, I'm going towards negative infinity. And then the horizontal asymptote asks the question, what happens as x goes to positive infinity? And on this end, what happens as x goes to negative infinity? But as I mentioned in the previous video, for rational functions, there is always, if there is a horizontal asymptote, there is one. There are rational functions without horizontal asymptotes, and there are rational functions without vertical asymptotes. But what we're going to try to do in this video is to determine what makes a vertical asymptote. For example, y is the vertical asymptote for this graph. One of them is the equation x equals -3, that's the left one. And one of them is the vertical line x equals 2, which is that one. So what about this function made those the vertical asymptotes? Let's turn off the horizontal for a minute. We'll discuss that later. Well, I bet you can figure it out. What's so special about the number 2 up here? It would cause a problem if we put it right here. If we put 2 right there, we would get 2 minus 2 is 0. 0 times anything is 0. It would cause the denominator to be 0. Same thing with -3. So it seems like the vertical asymptotes occur at the values that make the denominator equal 0. Or if you want to put it in the terms of the domain, it seems like the vertical asymptotes are the same values that are not in the domain. Now, let's put that theory to the test. We'll kill this whole function. It's interesting the things you get as you start deleting things. That's just an upside down parabola because the negative would distribute. Let's get rid of all this. And I'm going to set up an empty fraction. And let's put this theory to the test. Let's put something on the top like x plus 2. And this time, let's do the game backwards. Let's say that I want a vertical asymptote to occur at x equals 5. So let's go ahead and set up the vertical asymptote over here. What do you think I would have to put on the bottom of this rational function so that it would have a vertical asymptote at x equals 5? Hint, what binomial would equal 0 if you put in 5 for the x? There's actually 2 answers. There's actually a bunch of answers. Let's try x minus 5. X, not done, minus, I don't know what that means. Give me a number. 5. It looks like 5 is the vertical asymptote. Let's zoom out and look at the top and bottom a little better. Yeah. Pretty convinced that that's it. Now, if you wanted more convincing, we could drag up to the top where these seem to overlap. And let me get it kind of centered here. And we could start zooming in and see if the space between we can already see that there's a space between them. So it's an illusion that the graph is overlapping the vertical asymptote because the distance between the asymptote and the graph is smaller than the pixel size. Let's go back to home. All right, so I think we might be onto something here. Whatever makes the denominator equal to 0 seems to make the vertical asymptote. So let's put that to the test again. This time I'm going to turn off the vertical asymptote, and we're going to change the denominator. Instead of x plus 5, let's make it x plus 3. What number makes x plus 3 equal to 0? Oh, wait a minute, this one, right? -3, doesn't that make x plus 3 equal to 0? Let's turn the asymptote on, and it looks like it's the correct one. And again, if you weren't sure, if you were like, well, I'm not sure, just put this near the center if you're in Desmos and start zooming in, it's almost like you're plummeting from the sky, and you can see that there's a gap between there. And in fact, it doesn't matter how far up you go. I could go up to 10,000. Maybe I could Google jump up there. Whoa, okay. Everything, we're so far up in the sky, it just looks like it's not there. So let's center around here, and let's start falling to the earth. Whoop, I lost sight of the graph. Where'd it go? There it is. Let's put it back in the center. You can play all kinds of weird games with this. And let's keep plummeting towards the ground. Oh, got to recenter. Okay. That's how come I try to get it dead center so that when I zoom in, it stays in there. And it looks like everything's just sitting on top of each other, but let's zoom in a little bit more. I know that I know there's going to be a gap between them because I know the theory. I've taken those crazy math classes where you look at things, all kinds of crazy, and you prove things. And by the way, if you look, you can see how far zoomed in we are because these numbers represent numbers on the x-axis, and they're pretty close to each other. Let's zoom in some more. Okay, I'm going to do this until I find the gap between them to prove to you that no matter how far up the graph you go, there will be there it is. There's a gap between them. Well, look how zoomed in on the y-axis, on the x-axis we are. Negative 3.0002, negative 3.0004. But yeah, that just points out that no matter how close they look, there's always a gap between them. Let's go back home. All right, so it looks like the trick to finding vertical asymptotes is to figure out what makes the denominator equal to 0. But I want to show you something. I'm going to put a slider here where the 3 is. So let's just put V for vertical asymptote, and we'll add that there. So now, and let's call this one down here x equals, well, let's think about it. I think negative V would be the correct one. Yeah. Because if I put negative V where the x is, they would cancel and give me 0. So let's take out these because we don't need them right now. Okay. And so as I let this value of V oscillate, the vertical asymptote should move around. So let's try to get back. See? Now the graph's getting closer and further away. It's not a feature we're going to worry about. But let's animate this just because we can. Oh, whoa, slow down, slow down. Something happened there. Slow down. Okay, maybe not that slow. Did you see what happened? Let's see if we can pause it when it gets there. You know, I'm going to bring the horizontal asymptote in. We haven't talked about where it is yet, but I know it's at y equals 1, so let's just go ahead and put it there. That's not it. There it is. Let me make it dotted. Give me 1 second here. Sorry, I don't mean to turn this into a lesson on how to use Desmos, but let me make it a dotted red line just to look consistent with the vertical. Dotted red. Okay, done. All right, so let's back this up. Back up V. And I want you to watch what happens, because when I press this play button, the value of V is going to start increasing, which is going to change not only where the graph is, but where the vertical asymptote is. But I want you to watch. You see how the boomerangs are getting closer and closer here? Yeah, watch their, I guess, diagonal points, if you will. Well, they're getting closer to where these intersect. So here we go again. Hold on. Okay, and it's almost like where the asymptotes intersect are a big mass with pulling a lot of gravity, and it's sucking those branches in. But at some point they're going to meet, right? Whoa! Look at that. They're almost meeting. But watch what happens. Oh! Did you catch that? Let's back up and do it again. It's almost like they met and then they crossed over. So here we go again. And let's... But wait a second. What happened in between? Well, I want to try to capture exactly... Wait a minute, what's going on here? Where'd everything go? What's V equal to? Why is this flat? I don't understand. vertical asymptote, 2 branches, switch over to the other side, but in the meantime, it's almost like they meet and merge into a horizontal line. What's going on there? Where'd the asymptote go? I mean, we still see the vertical line, but if I were to turn it off, this doesn't look like, this just looks like a horizontal line. What happened? No, I don't want to be on the asymptote, I want to be on the function. I'm going to kill the asymptote for a second. I mean, the horizontal asymptote. I don't want that. Go away, go away. Okay. So what happened? I mean, there was a vertical asymptote at x equals -2, I believe. Yeah, -2 would make the bottom equal to 0 if this v were 2. But it looks like this graph just goes right through it. Doesn't even care that there was an asymptote. Whoa, hold on. Just wait. No. Dang it. Okay, I'm going to zoom in. Something popped up there when I crossed where I thought the vertical asymptote was going to be at -2. So keep going. Don't cross it. Don't cross it. Oh, you crossed it. Go back. Whoa, what? Did you see it? Did you see it? Whoa. What's going on there? Why would -2 make this undefined? Where'd the asymptote go? Why is there a hole in the graph? What's going on here? Wait, what's the value of v? Oh, v is 2. Well, what's wrong with having x plus 2 on the bottom? Uh-oh, there's x plus 2 on the top. Let me actually put the 2 where the v is. Gee, the bottom and the top of the fraction are equal, which means the fraction is equal to 1, which means this function is equal to 1, except at that hole in the graph. Where'd it go? There it is, undefined. What is going on here? I'll tell you what's going on here in the next video.